All right, before I get started officially, Claire, you have a hand raised. Is that still a question, or is that left over from previous lesson?
That's just from before.
Okay. No other hands, okay. So we're gonna be working with quadratics today, and we're gonna start with some of the easier ideas and then build it into the twist of what the ACT might throw at you. And so, real quick, can you multiply those? Are you really confident with being able to multiply binomials, and whether you use FOIL or distributive, different method? What happens with this is that instead we're going to look at the products of, okay, if we had x squared plus 15x plus 56, or x squared plus 1x minus 56, or x squared minus 1x minus 56, or x squared, thank you, minus 15x, my brain froze up for a second. So, very often you will see something about factor this problem. But in the hiding the answer, making it so that you can't really test answers, instead of giving you two answers that you could guess and check, they instead say, what are the sum of the two roots? And so here, it would be -7 and -8. The sum of the two roots would be -15. Here, it would be +7 and -8. The sum would be -1. Here, it would be -7, +8, +1. Here, it would be +7, +8, +15. So my question for you is, what's the pattern between, if this were our original problem, what was the sum of the two roots?
The opposite of the middle number.
The opposite of the middle number. You don't even have to factor it and re-add it. As fast as you could factor, if they ask you for the sum of the two roots, it's literally opposite this middle number. And so they might build off of that problem, and if they give you x squared plus bx plus c, they will mess with whether you understand this concept, and they'll ask you, what's the sum of the two roots for that problem?
B?
Almost. Opposite.
Oh, negative B.
Negative b. And so you can work with this concept from, oh yeah, I've got that, that's easy, to they throw it at you in variables. There are so many problems on the ACT that you absolutely could do if they gave you numbers. But because it's variables, it kind of makes you freeze up. If you happen to know the trick, woohoo, free answer, go for it. If you don't, go back to numbers. Go back to something that you do know and see if you could find the pattern of, okay, if I pick this thing and I factor it, what would the sum of those roots be? And you can see that relationship. Yes?
Will that be the same if it's like 2x squared? Or no?
No, because of the fact that it would multiply in. If it were 2x squared, you would actually be factoring out the 2 first. And you'd be working with, okay, I have 2x squared plus b over 2x plus c over 2. And it would actually be negative b over 2.
Oh.
And so you could work with it that way. Good question. working our way through quadratics, I'm assuming for most of you this is review. Most of what we're doing is at the Algebra 2 level, and then we kind of add those wrinkles that make it a little bit more difficult. So, with transformations, the problem that I wanted to do, I should have got this out earlier, I apologize. There it is. Where'd it go? Oh, there it is. So we have three parabolas graphed in the standard XY plane, and here's one, and they look like this. And we're told that n equals 1, n equals 2, n equals 3. So even without having the multiple choice options they give us, what's going on with this equation? Where would n be in our function notation or our equation?
In front of the x squared.
In front of the x squared. And so this parent function, or the standard one, looks like this. And so the n is multiplying everything and causing a vertical stretch by having it out front. And so the n would be x squared, and then we would also have plus 1 in this case because everything is shifted up 1. So this falls under the quadratic parabola umbrella, but I want you to apply this to any function because there are so many different transformations on the ACT, and sometimes they're parabolas, sometimes they're circles, sometimes they're sine waves, but it's so much with transformations. And so I want to talk about the general case of any function. You're going to have y equals function, but your main things are the sign, whether it's positive or negative. And then they used n, but the standard formula uses a, which is talking about the vertical stretch. And then it doesn't matter whether it's sine, square root, squared to the nth power, you have some version of the parent operation. Something is happening, whether it's being squared, square rooted, doesn't matter. But the parent operation says this is the basic graph. In this case it was x squared. But there are two ways to change this within the operation. Inside the operation, if you have something multiplying inside, that's going to cause a horizontal stretch. And if you add or subtract anything inside, that causes horizontal shift. So again, whether this is squared or square root or sine, any operation is going to follow these same patterns. Could be absolute value, who knows. But then finally, at the end, we have that vertical shift. So, what does the sign change do?
Flips the graph.
That's the easy one. If it's negative, it flips. If it's positive, there's no change. And usually this would show up as -3 or -1/2 or positive with nothing written 1/4. I want you to think of the sign and then the magnitude of this number as two separate things because they do very different things within that transformation. And so if you can separate them out, okay, pay attention to the sign, positive or negative, it does this flip, and then you look at how big the number is, it makes your life a lot easier. So, vertical stretch. If it's 1, the default, there's no change. But if our A is less than 1, what happens?
It compresses.
It flattens down. It makes it grow less quickly or shrink less quickly. It swishes it down. So A less than 1, but still greater than 0, because we already take care of the sign over here. It flattens. And if it was greater than 1, it stretches. The horizontal stretch on a lot of these would do kind of the same thing. The only time you're going to see this one is in sine waves or cosine waves because it affects how fast it goes up and down within the boundaries of top and bottom. But I would like you to apply logic to this. If it is a big number, it's going to go up and down lots faster. It's going to cycle more quickly. And so if B is greater than 1, it's going to compress horizontally. It gets quicker or shorter. And if it is less than 1, if it's fractional, it's going to happen much more slowly. It's going to drag out how long this takes. And so if our B is less than 1, but still bigger than 0, it is going to stretch. Horizontally. And so you're probably more familiar with the one we're going to talk about next. But know that inside the operation, it does the exact opposite. Before, if it was bigger than 1 outside, it stretched. But inside the operation, if it's less than 1, that's what causes it to stretch out. It's the exact opposite of what you've done before. And then H, horizontal shift, again, this is going to be the exact opposite. If it's minus H, it's going to go H right. If it's positive H, it's going to go H left. And the reason for that, the best one that I can give you to help you find, I find that with a reason why it's going to stick in your brain a lot better, if I have x minus 2 squared, the original low point of the smallest it can get is 0, right? Because it's getting squared. What makes this 0?
Positive 2.
+2. And so the lowest point of the graph is at +2. That's the lowest it goes. And so this shift, it's gone 2 units to the right because +2 is what creates that low point, what makes it 0. And so if you understand why, it's a lot easier to remember to do that opposite versus just trying to memorize, oh yeah, it's the opposite inside. That means nothing. And then finally, adding a number at the end is really easy. It just picks up the graph and plops it up higher. Or if it was minus, it would take it lower. And so those are the transformations. It's good to know for quadratics, but if you remember it works for everything, it's a great big hammer that works on all sorts of stuff. I am big on multitaskers. So this format right here is called vertex form. Why would it be called vertex form?
Because it plots the vertex.
Because it tells you the vertex. This horizontal shift gives you the x-coordinate. The vertical shift gives you the y. And at x, y, that is the vertex. So we started with factored form, and then we multiplied it out to standard form, and now we've seen vertex form. All of them have their uses. They're all different tools for talking about quadratics. But we're going to go back to the beginning. Quadratics can fall into 3 categories. The 3 categories look like this, look like this, will look like this. I threw in a negative just to show that it's possible, so don't worry about the direction it's opening right now. What are the 3 categories that we have for quadratics?
2x intercepts, 1x intercept, and no x intercepts.
Okay, so x-intercepts, and I agree, there are 2, 1, or 0. What is another name for those x-intercepts?
0.
Zeros. All right, any others?
Solutions.
Solutions. They will use all 3 of these interchangeably. And so knowing that that's what they're talking about, no matter what way they phrase the question, if they ask about x-intercepts or zeros or solutions, they all mean the same thing. These points where it crosses the x-axis, these points where it is y equal to 0, all of those things. So, we talked about factoring already a little bit, and again, I'm not going to hit that one too much. I'm assuming you're good at that. But let's say you're not good at factoring. What is the universal hammer that solves any quadratic?
Quadratic equation.
Quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2a. If you use that quadratic equation, to solve that problem, sorry. This, if you use it to solve that equation, you are wasting your time and should get a little bit better at factoring. But if you don't know how to solve a particular quadratic equation, this one is the universal solution. It solves any of them, no matter what form they're in. How many of you have this memorized? Raise your hand if you're online. Okay. Do you know the 3 pieces that you can use with this equation? You've already gone to the trouble of memorizing it. You should know all of the tools that you can use with it. So, the first one is, yes, this gives you the solutions, the zeros, the x-intercepts, whatever you want to call it. I'm going to call it solutions. But, what is this plus or minus about? Why is it in there? Let's take this one.
Oh, there's always 2 solutions to an x squared.
Yeah, it's plus or minus. It's about the wobble away from the center. It's plus this or minus this. What that tells us then what does just negative b over 2a give us?
Axis of symmetry.
The axis of symmetry. It tells you where this middle is. And it doesn't matter if it's a 0 solution, a 1 solution, or a 2 solution. This negative b over 2a is going to tell you where the center is. And so you don't have to memorize it separate. It's just they're part of your quadratic equation. But negative b over 2a is the axis of symmetry. And if you happen to need the vertex and it's been given to you in standard form, you find your axis of symmetry, that's your x-coordinate, plug it into the equation, it spits out your y-coordinate. You've got your vertex. And so again, you don't have to memorize an entire new formula. It's already in the thing that you memorized, as long as you remember, oh yeah, this first part, that's what I'm wobbling away from. The second, or the third thing, I suppose, because we already talked about solutions, axis of symmetry, the third thing you can do with this equation is use the inside. Because, let's talk about what happens. If this ends up being a real number, perfect square or not, but if it's a real number, we have plus or minus, that creates our wobble. That's the 2 solutions. But, if instead, what if this ends up being 0? It disappears perfectly into just 0. Does plus 0 or minus 0 change anything? So how many answers do we really have? 1. And so if this equals 0, that is our 1 solution. And finally, what happens if this ends up being a negative number?
No solution.
No solution, or no real solution. They're still imaginary ones, but there's no place that it is crossing that x-axis. And so, if you don't have the graph, you can look at just this part, and it's called the discriminant. It tells you what kind of answers you are dealing with, whether 0, 1, or 2. So again, as long as you've already got it memorized, you've got a lot more to use with it than just, hey, what are my answers? And it's already in your brain. Alright, we're making good time. I do want to get to some practice problems at the end. I will not feel offended. So far, is it being helpful? Okay. Alright, so with that, if I have y equals 2x squared plus kx plus 32, what value of k will cause the function to have one real root? Right. First of all, how many of you made your life easier before you went to the quadratic formula? Nobody? Okay. One of the things that you can do is get your numbers as small as possible. Well, give yourself an A here, and then you can deal with that 2 later. So we're trying to find out what will cause the function to have one real root. What makes one real root happen?
When the table is here.
Hmm?
When the b squared minus 4 is easy.
Okay. So, but that will happen with perfect squares. In order for that equal to 0, you have to have 2 things being the exact same. X minus, I'm going to use C for a constant, but it could be plus, and it probably is plus given this situation, but you've got to have them being both the same root. Another word for a one solution is a double root. The 2 factors would have to be the exact same in order for that to happen. So that's what's going on, but we go back to b squared minus 4ac. So, oh, I shouldn't use a there, that's bad. We'll use k. K is a good one. And so we're going to have k squared minus 4 times understood 1 times 16, and we want this to be equal to 0. So what will 4 times 16 equal? 64. So we end up adding that over. We have 64 equals k squared. What is square root of 64? 8. So for the purposes of this problem, because I didn't put the multiple choice up here, that's good enough. But remember, when you take the square root, you should be considering positive or negative 8. And so put that back in here. What's 8 times 2? So this would be 16 or possibly negative 16. Both would work. Did it work with just running the number without pulling the 2 out? And it still works. So that would be like 55 to 60. They would throw that at you. Because of the multiple layers of, you have to understand what makes one solution and work through the solving. That's one that they'd throw at the end, particularly those things with variables in them. So this one is much easier. It's earlier in the test, but I want to talk about a particular thing that again makes your life easier. Is anybody in Algebra 2 currently? Okay, so you finished Algebra 2, so you know about simplifying equations all over the place. What is the huge trick, easy, make your life better when you're simplifying these equations?
The x.
The x?
Like the you multiply a times c on top, and then on bottom it has to add the 8.
Okay, so that is the technique. The trick on these is actually easier. They are asking you to simplify. By asking you to simplify, guess what? You know it simplifies. You know that something is going to cancel. Whereas a real problem in the wild, maybe it cancels, maybe it doesn't. But because you know it's going to cancel, you know that this is going to be one of the factors of the thing above it. You're not starting cold. You know that one of these factors is going to be x plus 1, and this one's pretty easy. The only other thing possible is x plus 8, or sorry, 7. You know that x minus 3 is going to be one of the factors here. And so the only other thing is going to be, okay, in order to make negative 21, it needs plus 7. And you can really go quick double check that, yes, x squared, and then 7x, negative 3x makes 4x, negative 21. But you don't have to go hunting from scratch. You don't have to consider all the possibilities. They've already given you those pieces. You've got a really good guess of what the factors are going to be for that factoring part of the problem. And so that just makes your life a little bit easier. Definitely not a hard problem, but just wanted to give that hint of, they gave you something to cancel, it's got to show up in that part that you're factoring out. All right. We've got a good amount of time left. Let us go to some sample problems. And the tests I looked at did not have a whole lot of quadratics, and so I was having to pull from old things. All right. ACT quadratic. So again, they like to put variables in it. Don't be intimidated. If x squared minus 45b squared equals 4xb, what are the two solutions? And while you're working on that one, I'm gonna put another one up over here. And I apologize, I try and put numbers for reference. This was a problem 54. Are you done or still working on this first one? Okay. Give everyone 1 minute. Okay, we're good. So, first and foremost, remember that if you're solving anything, you want it equal to 0. So don't start trying to figure out what can I do with this until you've moved this part over and you get that equal to 0. So we have x squared minus 45, and actually I'm going to stick the other one in the middle. X squared minus 4xb minus 45b squared equals 0. So what's the general structure of solving this? What do we need to do? Are you confused by what to do next or by my phrasing of the question? Yes?
Factor it.
We're factoring it, and the general structure I'm talking about is, what do we know about this structure? What's gonna be what's gonna look like our answer, or what form is our answer gonna be in? Because we have x squared, and in particular because it's a quadratic, we're gonna have x and x. Because we have this b squared at the end, we're also gonna have b and b. But if you understand that structure, from now on you kind of get to ignore the variables. If it's easier for you, all you're doing is solving x squared minus 4x minus 45. And so if that's easier for you to work with, understand that's what's going on. As long as you understand this x squared will cause an x in both terms, this b squared will cause a b in both terms, you can ignore this for the rest of the problem. If you understand the structure, now that's one less thing to balance in your brain. So, what do we know about the signs of our two solutions?
One's gonna be positive and one's gonna be negative.
One's gonna be positive, one's gonna be negative. And we're looking for the numbers that go out front.
Plus 5 and minus 9.
+5 and -9. All right, that would create the -4. Are we done? No. The one thing that'll trip you up because you get going and you're like, yes, I've got it. Remember, we are looking for the solutions. We need those opposite numbers. And so our two solutions would be negative 5b and positive 9b. So don't do all the hard stuff and then drop it at the very end. Make sure you are answering the form that they asked for. And I say that not because you're stupid, but because you're smart and we get ahead of ourselves sometimes. All right, go ahead and tackle that one. So, you've been through Algebra 2, you don't need me preaching to you how much difference of squares shows up. Difference of squares shows up a lot, and so this is going to factor into x minus 3 and x plus 3. Again, since we're simplifying, we know that one of these two is going to show up in the top. And so we're not worried about 1 and 6. We don't have to consider that case. We're only looking at 2 and 3. Which one's going to be the positive one? X plus 2 and x minus 3 in order to get that negative in the center. And so the x minus 3's cancel, and we have x plus 2 over x plus 3. So, again, pretty straightforward, but just be really super confident with that difference of squares. It'll show up somewhere in some form. This one is extending into the imaginary numbers a little bit. You're going to work more with that later. But if they ask us to multiply this, multiplying fractions across the top, across the bottom, across the top, doesn't change much at all. We have 1 minus I squared. And the important thing to know is that we treat these just like binomials. And so when we multiply this out, what do we get here on the bottom? Still in terms of I. Don't simplify too far yet.
1 minus I squared.
Yeah, because we have 1, and then it's going to do that plus minus cancel difference of squares again. And so we have minus I squared. But they told us that I squared, oh sorry, I've got an extra squared in there. So there's our top, there's our bottom. Okay. I squared can be replaced with -1. What's minus -1?
Plus 1.
Becomes +1, or 1 plus 1 is 2. So we have 1 plus I over 2. Yes.
Is it one minus side or one plus side?
It's one minus.
Should
Oh,
be minus.
thank you. Copy error. Thank you. If you're in my classroom, it's worth extra credit. I have no extra credit here. But correct teacher is always better than having wrong answer on board. All right. Last one. Again, we're extending into the new stuff, but you've done well enough on the basics that I'm okay with it. So, a circle has a radius of 3. And center at 0, 0. You don't have to know the equation of that circle, just know that's what it looks like. But a parabola has a vertex at -3, -2. And it has a vertical axis of symmetry, so that just means it looks like that. And it passes through -2, -1. So the question is, how many times do the parabola and circle intersect? How many crossing points would there be?
Two.
So, this is a very conceptual problem where you're understanding what's going on. If the radius is 3, it's going to be meeting at these 4 points and just curving through them. If our vertex is at -3, 2, it's the same lineup as right here, but it's only 2 down. And the fact that it passes through -2, 1 tells us that it's going over 1, up 1, or that it's the general basic shape of a parabola. If possible, get familiar with those first couple points of a parabola. They help you a lot to know, okay, this is up 1 over 1, this is up 1, backwards 1, and then it'd be over 2, up 4,
Three.
and
Wait, up. Oh wait, never mind. I'm wrong.
so it's at +3, but it's 4 from your starting point.
Yeah.
And so if you can treat this like a little mini origin and know that's the general shape of a parabola, that helps a lot.
Yeah.
And so-
I was saying 3 because like. when
Yeah,
I
but
did
it does meet at 3. It is +3. So, oh, and you're thinking 3 away from the last
Yeah,
one?
yeah.
Okay, that's another way to memorize it. So here, we know that this side is completely clear of the circle because it is, axis of symmetry is right where that circle boundary is. And so it goes and misses it completely, and then here, it crosses through twice. And so as long as you understand this is what's going on with the parabola, this is what's going on with the circle, relatively quick solve. But it's a very, what are the roots of what does a circle behave like? What does a parabola behave like? All right. So, last thought for you. Again, it's a little bit easy, but I like things that help your brain stick. How do you know if a graph has a minimum or a maximum as a parabola? If you just look at the equation,
If it's positive or negative.
if it's positive or negative, which one goes with which?
Positive goes with, has a minimum, and if it's negative, it has a maximum.
Yes. So, if it's positive, it's miles. If it's negative, it frowns. And so that's a really easy connect in your brain. What is it gonna look like? And with that, you're done. Any questions, whether from homework, from this, anything that I can clarify for you? All right. I'll have to look at my calendar. I don't remember when I'll be back next, but in general, I forgot to introduce myself, didn't I? But in general, my name is Aubrey. I teach high school math, and bring me questions, whether it's from your homework, whether it's from something else. It always is a good teaching moment, and 3 other people will be glad you asked because they're feeling scared. So, bring me questions. And that is it.